Uh, so welcome everyone. Welcome to today's session, and today's session is on the OPAMP and filters. So basic OPAMP I have already taught you, and I referred that lectures yesterday. I hope that you have watched those lectures. Today my agenda is something different. I am basically going to do one or two basic OPAMP questions. All of them are CSIR net PYQ questions. And then I will move to the 2 or 3 good quality questions, which are basically telling you how to find the gain of the circuits, how to find the phase difference of between input and the output. And this lecture series means this OPAMP will go for 2 or 3 days, and because OPAMP is one of the most important topic of CSNet. Every year, somehow, in one way or other, they ask the OPAMP question. Sometimes they ask the filter, sometimes they ask the multivibrators, sometimes they ask the amplifiers, sometimes they ask the RC shift filters added with the OPAMP. So they do too many things with the OPAMP. They just don't let OPAMP remain as such. They do many things, and I will tell you 3 to 4 different, in 3 lectures, I will tell you 3 different categories of things that can be done with OPAMP. And today's category is starting with basics, and then we will go for the phase shifts and the gains. Okay, so let's do that. So number 1 is the basics of OPAMP question, and this is something like this. Now you have in front of you something like this. So you have a circuit, and this is your OPAMP circuit. And in this OPAMP circuit, they are saying that what is the voltage at this point A. So what is the voltage at this point A? Now, according to the OPAMP rule, uh, it is known as the principle of the virtual ground. So principle of virtual ground. Principle of virtual ground says that both the inputs of the OPAMP, I will repeat, both the inputs of the OPAMP are at the same voltage. So if the voltage at this point is V, then the voltage at this point is also V. So the input of both the inputs of the OPAMP are at the same voltage. And the reason for that is that OPAMP has infinite internal resistance. No current can flow in the OPAMP in the inner side. It means no input current can be there. So if there is no current, it means the voltage difference is 0. So if the voltage difference is 0, it basically means that both the inputs are at the same voltage. Okay. So if I can find the voltage at this point, I can find the voltage at point A. Okay. So if you have already watched my lectures, can anyone tell me that what is an answer? What is an answer that I can expect?
0.5, sir.
0.5 volt.
0.5,
Perfectly
sir.
fine. 0.5 volt. And the reason for that is that let's look at this circuit. Let's look at this bottom surface circuit. Sorry. So this side is at 1 volt. This side is grounded. So grounded means 0 volt. And I need the voltage at this point. So if this is A, then this is also A, because I just said that voltage at both the inputs is same. So if this is A, then this is also A. So this point is A. Now what will happen is that what is my total voltage difference from the very starting to the very end? So my total voltage difference is 1. From the beginning to the end, my voltage difference is 1. If I pass through the 1k ohm resistor, I will lose some voltage. Some potential drop will happen. So if I pass through this 1k ohm, how much potential drops? V1. And then if I pass through the second resistor, again the voltage drops, and that is also V2. Okay. And the very simple rule here is we have to use the voltage division rule, that what is V1 and what is V2. Voltage division rule is very simple. If your voltage has to divide between the 2 resistors, means your total voltage is V, and it has to divide in 2 resistors, R1 and R2, then the voltage across R1 is total voltage multiplied by R1 divided by R1 plus R2. The total voltage in this case is 1 minus 0, 1. 1 minus 0, 1. R2, both the resistors are same, 1, 1. So 1 divided by 1 plus 1 is 2. So this is half volt. Similarly, if you find the voltage at second resistor, that will be total voltage into second resistor divided by R1 plus R2. ठीक है? So total voltage is V1 and R2 is 1, R1 R2 also 1 1. So 1 by 2 is again half volt. So out of the total 1 volt, so the total was 1 volt, half volt is dropped here and half volt is dropped here. So if you start from 1 volt and you pass through the two resistors, resistor number 1 and resistor number 2. So if you pass through resistor number 1, half voltage is gone and you are left with this half. And then you again pass through the second resistor, again the half is gone and you are left with this 0. So voltage at this point is actually half. So you started with 1, half is dropped, so you are left with this half. So the voltage at point A is 0.5 volt. Any doubts in this question? Yeah. Is it clear? How I came to this half? Yeah. Very quick. We have to move on. Yeah. Is it done?
Yes, sir.
Okay. Good. Let's go for the second basic question. This is another basic question, and what I will do in this question, I think this you can do it. Okay. I have already also covered in the lectures. You tell me, is it something you can do or is it something I should do? Yes, you can do nodal analysis. Yeah, you can. Yeah. So what do you say? Is it doable? If you have watched the lecture, only then you tell me. If you have watched the lecture, do you think this can be done? I have discussed such questions in the class. Yeah. If you will want me to do it, just tell me, but don't keep in between. If you want me to do, I will do it. What do you say? बोलो यार, कुछ भी बोलो, anything. ठीक है, कर लेते हैं. If you're not saying anything, let's do it. ठीक है. So let's do it. So you have a voltage of 1 volt in the input, and then you have three resistors, 1, 2, 3, 4 resistors actually. And then they are saying that what is the voltage at output. So what is the total voltage at the output? ठीक है. So the total voltage at output, yes, answer is C. So what is the total voltage at output? This is what they are asking. Okay. So the voltage here is asked. So if this is V output, then this is also V output. Okay. Perfect. Now in an op-amp, what happens is that whatever is a current coming from here. So let's say some current is coming from here. Now no current can go inside the op-amp because you know that input current in an op-amp is 0. No current can enter the op-amp. So whatever current is coming, so whatever input is current is coming, it will go in the feedback loop. So this kind of loop is known as the feedback. Feedback means connecting output voltage to input voltage. Okay. So I do some efforts, I get an output. Until unless I don't know the output, I have no feedback. So if I do some efforts, my op-amp is doing some efforts and output is there, and then that output is connected back to input. So this output is connected back to input so that I get a feedback. Okay, my op-amp gets a feedback. So whatever current comes in an input, the entire current goes to the feedback because no current can come from here and enters the op-amp. This is not possible. So no current can come, no current can come, no current can come, no current can come, and then it cannot enter the feedback. It cannot enter the op-amp. This is not possible. So that is why the entire current goes to feedback. So the current in input is same as the current in feedback. So the current in input is same as the current in feedback. Now let's do the simple maths. Let me remove all of this. The voltage at this point is 1 volt. Simple. The voltage at this point is 1 volt. Voltage at this is 0. So if this is 0, then this is also 0. The principle of virtual ground. Both the inputs should be at the same voltage. So voltage at this point is 0. And this point is V output. So this voltage is V output. So what is the current here? The current here is What is the current in the input? 1 minus 0 by R. We just saw in the last class 1 minus 0 by R. So 1 minus 0 by resistance, which is 1K. So let me show you this 1 minus 0 by 1K. Okay. Similarly, sorry, something is stuck here. Yeah. So it will be back. Just a second. Yeah. Okay. Okay. So the current in this case is 1 minus 0 by 1K. Okay. And current in this is 0 minus V output by 1K. So 1 minus 0 by 1K equals to 0 minus V output by 1K. So this is what the maths I will do, and I will make both of them same, because whatever is the input current, the entire current goes to feedback. So 1 minus 0 by 1, 0 minus V output by 1. So from there, my V output comes out to be minus 1. So that is my answer. So my V output is minus 1. And that is my final answer. And my option number C will be correct. Any doubts here, anyone?
Sir, if positive and negative terminal are interchanged, then answer same?
No, then it will. Then it is a what do you say? Non-inverting amplification, right? Then you know the voltage will be same. Infinite gain will be there, right? So then the voltage will be same as the voltages. You know that in an OPAMP we have this as these voltages are also there, which are not shown, but they are there, right? Saturation voltages 10 volt minus 10 volt, right, or something like that. Then your output will be this 10 volt and minus 10. Then the saturation will be there. So infinite gain means, what does op-amp do? So whatever is an input, it doubles up, it gains up. So if the gain is infinite, then one volt should become infinite volt. But infinite volt cannot be an answer. I cannot have infinite voltage. So what will happen is that maximum voltage that I can have is whatever I have applied. I have applied 10 volt to run my amplifier. I am using 10 volt to run my amplifier, which is not shown here. Actually, it is not shown in the question, but it is there. And if the question is something like that, it will be shown there. In this, it is not shown because you are in a negative feedback. Negative feedback means that the gain is not infinite. The gain is little less. Shouldn't the direction of IF from so but I will use the standard notation. No, voltage automatically comes. How will? No. The voltage here is 0 and voltage here is minus 1. Right. So the current will go from 0 to minus 1, right? Right, isn't it? The current should go from 0 to minus 1, not from minus 1 to 0. It goes from higher. So 0 is higher number than minus 1. Right? Perfect. Any doubts in this question? So, okay. Now I want to come to the questions which has op-amp and also capacitors attached. So op-amps are connected with the capacitors. These kind of problems are actually very interesting, and this is something you will not find usually in your books, but CSIR net is very much uh, favoring these kind of questions. Okay, so let's do that. Let's analyze the circuit first. So there are two things in our circuit. One is the feedback circuit. So this is the feedback circuit. So this is a feedback circuit. Okay. And then you have an input circuit. This is an input circuit. Okay. And input voltage is given. So you are given the input voltage. So this is your input voltage, circled one. And this is given by 5 sine 1000 t. Basically, it is changing with time. It is changing with time. So omega is 1000. because usually it is written as sine omega t, and whatever is outside is an amplitude, is an amplitude. Okay, so amplitude is 5, omega is 1000. That is the two things which is given. Now what they are asking is that what is an amplitude of the output voltage. So basically I need to know that what is in my output voltage and what is the amplitude of that. Whenever you need to do such questions, input is given and output is asked, you need to know the gain of the OPAMP. How much is the gain of your OPAMP? So gain of the OPAMP means that how much your OPAMP is able to increase the voltage. So basically this is defined as V output by V input. V output by V input. And that is defined as minus of J feedback by J input. So whatever is an impedance, not a resistance, impedance of feedback circuit divided by feedback of input circuit. Why I'm saying that it is impedance, not resistance? Because if you only have a resistor, then it is resistance. But if you have resistor, capacitor, and resistor, all three, inductor can also be there, capacitor can also be there, resistor can also be there, then you will not define the resistance, you will define the impedance. How do you define the impedance? So it's a very simple thing. All you need to know is that what is the resistance of capacitor. So the resistor of capacitance, resistance of capacitance, how much is the resistance of capacitance? So the resistance of capacitance is 1 by omega c, 1 by omega c, and that is known as a capacitive inductance or impedance. Okay. And if someone asks you also about the phase, that tell me what is a phase, then you multiply by J. J is a complex number, iota. So in electronics, iota is represented by J. So iota is represented by J. So this is the resistance of your capacitor. This is the resistance of your capacitor in your circuit. So let's start doing the question. And there is a negative sign, and this negative sign is there because you have an inverting terminal. So feedback is converted to the negative symbol. It means it will reverse the voltage. Means if it is plus sine omega t, then it will make it to be minus sine omega t. Because this is what inverting terminal do. It reverses the situation. It brings the gain. Okay. Now let's talk about the impedance of the feedback. So let's find the impedance of this thing. This feedback circuit. Okay. In the feedback circuit, you can clearly see, I hope you can see. Can you see that the capacitor and resistor are parallel to each other? Is it there? Is it true? Everyone can see that capacitor and resistor are parallel in feedback circuit. No doubt in this, right? Yes. Everyone understands. Clear? Okay. So if two people are in parallel, then what is the resistance as such you can find out? How do you find the resistance? R1, R2 by R1 plus R2. R1, R2 by R1 plus R2. So one is the resistor, another is the capacitor. So RF into XC divided by RF plus XC. So let's first find XC. What is XC? XC is defined as 1 by J omega C. J is the iota thing. Omega is given by 1000, which is 10 to power 3. And the capacitor is given by 1 microfarad. 1 microfarad means 10 to power minus 6. So XC comes out to be 10 to power 3 by J. Okay. So I put my value of XC. So XC, and also my feedback resistance is given by 1 kilo ohm. So it is 10 to power 3. 10 to power 3. So I put my RF, which is 10 to power 3. I put my XC, which is 10 to power 3 by J. 10 to power 3 by J. Then I again put my RF, which is 10 to power 3. And then I again put my XC, which is 10 to power 3 by J. 10 to power 3 by J. When I do all of this, then I can do the calculations in much simpler way. I can do all my calculations. I can take 10 to power 3 common. I can multiply j inside. So all I'm left with is j 10 to power 3 divided by 1 plus j. Simple. 10 to power 3 by 1 plus j. So that is my feedback impedance. Now let's talk about the input impedance. Okay. So in input, if you carefully see, in input, there is only one resistor, nothing else, just one resistor. Nothing else is there. In input, only one resistor is there. So my input impedance is only 10 to power 3. So my input impedance is just 10 to power 3. Okay. And now I can do my gain. So gain is V output by V input. Okay. V output by V input and JF by J input. Feedback impedance divided by input impedance. So if I divide this and this, J feedback and J impedance, so this you can see 10 to power 3 by 1 plus J divided by 10 to power 3. So 10 to power 3 and 10 to power 3 cancels. And can anyone tell me why I have multiplied and divided by this 1 minus J? Why I have multiplied that? Very simple. Why I am doing this? What is the word? What I'm trying to achieve by doing this? By multiplying 1 minus J and yeah, sorry. I'm just trying to do rationalization, right? So you know what is rationalization, right? So bringing the complex number on the numerator, right? To make the denominator real. Yes, I want to make my denominator real. So if I do 1 plus J into 1 minus J, so it is A minus B into A plus B. So it is A square minus B square. So A square minus B square. 1 minus iota square is 2. So that is why I see this 2 here. And in the numerator, I have 1 minus J. 1 minus J. So finally, what I got is a complex number. It's not a real number. I have got is a complex number. If I give you a complex number and I ask you the modulus, for example, I give you something like this, A plus iota B. Okay. And I ask you the find the modulus of this. So you will do A square plus B square under root. This is how you find the modulus of a complex number. Simple. Class 11th mathematics. So in this case, my A is half and my B is also half. So if I do A square plus B square, I will get half square plus half square, which is basically 1 by root 2. Simple. So my V output by V input is 1 by root 2. Then what is my V output? So V output is nothing but V input. So I just take this V input on other side. So if I take V input on other side, I will get V input by root 2. And V input is defined as 5 sine omega t, right? And it is dividing by root 2. So again, I do the same thing. I multiply divide by root 2 root 2. So if I multiply divide by root 2, I get 5 root 2 by 2 because root 2 into root 2 is 2. So in the new denominator, I get 2. So nothing, I just multiply divide by root 2. So root 2 becomes 2 and it becomes 5 root 2. So this is your amplitude of the output. This is the amplitude of the output and amplitude of the output is 5 root 2 by 2. And let's check the options if there is any. So there is option number C, which is available. So option number C is 5 root 2 by 2. Okay. Any doubts with this question? I think I have simplified as much as I can. Any doubts, anyone? So how to find gain? Gain is V output by V input. And it is defined as feedback resist impedance divided by input impedance. In feedback, I had resistor and capacitor parallel to each other. And the resistance of the capacitor is defined by 1 by j omega c. I just did the maths. I got the complex number. I find the modulus of that complex number. And I got my gain. Any doubt, please? Please. Is it clear? Basically. Okay. Yeah, sure. I can scroll a bit, please. Yeah. Till to this point. Today there is a lag a little bit. I don't know why. Yeah. Little bit more if you want. Yeah. Okay. Okay. So let's move to the next question. This is a second question. Let's have this question. Another question that is there in an op-amp, the circuit is shown in the figure. Now we can do it little quick. And again, you see that there is a feedback circuit here and there is an input circuit here. So feedback circuit is there, input circuit is there, and the frequency is also given, and it is 10. So 10 is the frequency which is given. They are saying that find the magnitude of the gain and the phase shift. How much is the magnitude of the gain and what is the phase shift? Do you think that is it a new question or is it same question? What do you say? Uh, Gain wise, it's the same question. What is the difference in this question? They are not only asking the gain, but they are also asking the phase shift. So how do you do the phase shift also? So let's do that. Okay, so I will quickly go through this question, and the question is something like this. Again, I will use the same thing. I will find the gain by doing V output by V input, which is JF by JI. JF is the feedback impedance divided by input impedance. Now, in the feedback, I have two people. One is capacitor and one is resistor. Both of them are parallel to each other. So if you do have two things which is parallel to each other, then again XC. So I'm calling this as R2. So XC into R2 divided by XC plus R2. So then I go on and find XC, and then XC is 1 by j omega C. XC is 1 by j omega C. J is j. Omega is 2 pi into frequency. Frequency is given as 10 because omega is given by 2 pi into nu, and nu is given as 10. And then the capacitor is given. Capacitance is 0.01 microfarad, which is 10 to power minus 8. And all of it you get at this answer. You get this answer. Clear? So this is your XC. And then you find your JF, total feedback. Don't you think that, okay, who is the second person in this? Second person is resistor. The second person is resistor. One is a capacitor and another person is resistor. So the second person is resistor. So that basically is 10 to power 4. 10 kilo ohm is 10 to power 4. Don't you think that your XC is much larger than your R? XC is much larger than your resistor because XC is almost 10 to power 7. R is 10 to power 4. It is 1000 times greater. So what I can do actually is I can ignore my R with respect to XC. So if I can ignore my R with respect to XC, so if I ignore this thing, then you can clearly see that XC and XC will cancel out. So 2 is in denominator. Okay, fine. Yeah, okay. Where are you saying? Here, okay. Doesn't matter. Doesn't matter. I just want magnitudes. So 2 should also come. Okay, perfect. No. No, actually it should not come. It should. Okay. So if XC is much larger than R, then R can be ignored with respect to XC. And then what happens is the XC and XC in the numerator and denominator cancels each other out. And the final resistance that you get is just R2. And that is almost 10 to power 4. R2 is only 10 to power 4. And that is your final impedance of the feedback circuit. Similarly, what is the impedance of the input circuit? The feedback of the input circuit is 1K. Let me show you that. Feedback of the input circuit is 1K, that is 10 to power 3. So 10 to power 4 by 10 to power 3 gives you 10. 10 to power 4 divided by 10 to power 3 gives you 10. And that is defined as the gain. So your gain is 10. And the phase difference is negative. Why? Why I'm saying that? Because I told you in the last class, because it's a inverting terminal, so it will invert. So if there is a sign of negative, what is the phase difference? If you have a negative sign, what is the phase difference in angles? In terms of angles, what is the phase difference? 180 degree, or you can say pi. Because if this side is positive, then this side is negative. then it means they both have the angle of 180 degree. So it basically means that the phase difference is pi and the gain is 10. So your answer number D is correct. Is this question crystal clear to all of you? Any doubts here? Is it okay? Any doubts here? Yeah, there is a formula. How phase difference is pi? So see, negative sign, it is connected to the negative terminal. So whatever voltage, so in the last lecture I said na, that gain V output by V input is negative of J feedback by J input. Now J feedback by J input you come out to be 10. So the final answer is minus 10. So minus means pi. Minus, why minus means pi? Because if you do this, let me show you this. E raised to power iota pi. Using the de Moivre's theorem, what you can do, cos pi plus iota sin pi.
Minus
Now,
1 plus 0.
yeah, so cos pi is minus 1, iota sin pi is 0. So your final answer is minus 1. Okay? So that is why whenever you see a negative sign, you say that phase difference is pi. Because if this is one side, then this is another side. Both of them are negative to each other and they have an angle of 180 degree with each other. That is why your phase difference is pi, but the gain is 10. No, it is not pi in every case. In the next question, it is not pi, and you will see why. Okay. So this is your second question, and the third question is your homework. Actually, you do the maths for this. Fourth question I want to go through, and these all are the CSIR net PYQs. So CSIR net PYQs is asking a similar kind of questions again and again. So I have summarized all of them together, and you will enjoy this. Okay. So last question for today, and you will see this question. The gain you will find, but in this they are only asking the phase difference. So only thing they're asking is the phase difference. So let's see the question. In this, some things are given. So they say that in the circuit shown below, the gain of the OPAMP is 10 to the power 5. So gain is given already. And they said the sinusoidal voltage means the voltage changing with time is coming, and the angular frequency is 100 radians per second. And it is applied to the input. It is applied to the input. Okay. And now they are saying that what is the phase difference between input and output? What is the phase difference between input and output voltage? That's all they are asking. Okay. So let's see this, how we can do this. So gain is given, and gain is defined as feedback impedance divided by input impedance. Okay. Feedback by input. And in the feedback, there is nothing. There is only one resistor, and that is R2. So there is nothing. There is only R2 in the feedback. So I have written R2 here. Okay. Now, in the input, resistor and capacitor are in series. So I will say R1 plus XC, resistance of resistor plus the capacitance of capacitor, R1 plus XC. So now I will put all the values. I will put all the values. So R2 is 4 into 10 to the power 3, 4 kilo ohm. R1 is 2 kilo ohm, so 2 into 10 to the power 3. And XC is 1 by J omega C. So J is a iota thing. Omega is given as 100 and C is given as 5 microfarad. So that is why you see 5 into 10 to the power minus 6. What happens if I multiply by J and divide by J? Okay. So in denominator, you see J and J is J square, and iota square you already know is minus 1. J and J is J square and iota square is minus 1. That is why this plus becomes negative. Negative here. And there is a J which is in the numerator, which you can see here. Okay. And this becomes 4 into 2 10 to the power 3 divided by 2 into 10 to the power 3 minus J 2 into 10 to the power minus 3. So I can take 2 into 10 to the power 3 common from the denominator and I can cancel. So finally my function will be 2 divided by 1 minus j. I will again repeat the same thing, and I will again repeat the same thing. And what I will do actually is I will rationalize. So I will multiply by 1 plus j and I will divide by 1 plus j. So 1 minus j and 1 plus j is 2, because a minus b into a plus b is a square minus b square, and a square is 1 and b square is minus 1. So 1 plus 1 is 2. So you get 2. So 2 and 2 cancels and you are left with this 1 plus j. So this is your final answer. By looking at the final answer, you have to tell about the phase shift. Looking at the final answer, you have to tell about the phase shift. So let me remove this first of all. This is not true. Okay. This is not true. So you get a final answer of 1 plus j. Now I want to bring something in your mind, that V output by V input is actually minus of JF by J input. All you have done is finding JF by J input, which is 1 plus j. In reality, there should be negative sign also because of the non-inverting terminal. Now you have to think about this complex number. Now you have to think. So in this complex number, you see, can anyone tell me what will be the angle for this? For this, what will be the phase difference? What will be the phase difference? Angle wise. What is an angle? I think this is a very basic complex numbers. You should know that. Not 45 degrees. 45 is the wrong answer. 45 actually is a wrong answer. So you see your real part is also negative and your imaginary part is also negative. So your complex number is in the third quadrant. If both of them are negative, then it is in the third quadrant. So this is where your complex number will be, not minus 45. Minus, you have to be remain in positive. So this is your complex number. Now you do tan theta. So tan theta is imaginary part, which is 1, divided by real part, which is also 1. So now the angle comes out to be 45. This is 45. This thing is 45. Okay. You also have to add this angle, because the angles are always taken from the positive x-axis. So 180 degrees also added. So 180 plus 45 is 225, which is nothing but 5 pi by 4. 5 pi by 4. Why 45 everyone gets? The tan theta is equals to, and if you don't know this, go and watch my complex number lectures. I think this is something you should know. I think this is very fundamental that I asked you that what is an angle from this. Finding an argument and modulus is one of the most fundamental maths you have to do. Okay, and watch my complex number lectures. You need this. Okay, both are negative. -1 minus j means real part and imaginary part both are negative, so it is in the third quadrant. And tan theta is 1, it means it is 45 degree. But since you also have to add 180 because your angle is starting from positive x-axis, so total angle is 225, which is 5 pi by 4. So that is your answer, 5 pi by 4, which is your option number A. Okay, so option number A in this case is correct. So I close my session here. Any doubts if you have?